Okay. So if there are no other questions, let's start with today's session. Just to brief up, we did set up the local device with a couple of tools, and we tested by executing few commands such as echo, present working directory, listing files and directories on your system, and just getting familiarized with your system as an engineer or as a software developer. Because in a day-to-day life, when you use your computer, it is like a computer user. You are a consumer of different services, such as email services, e-commerce services, banking service, and so on. You might have also seen that government services are also across the globe. Different governments are putting their services in a digital form, so that less paperwork and more of a digital interaction with various services is possible. And everything from shopping, holiday, everything is based on internet and online services. So slowly and gradually we will move towards that approach, how the cloud native application development works and what are the significances of modern microservices based architecture. So just to brief you up, when we interacted with our system by running few commands and script, the technical term for that type of action is considered as you are interacting with your device with the standard inputs, which is like you're connecting your keyboard, or if it is a laptop, it is already integrated with your device. Your keyboard and mouse is there. You run commands and system is responding with some output. Now, if you type something like this, system will say that I don't understand what you're doing, right? If you type something like these numbers, it says I don't understand what you're doing, because every system has a pattern which it understands certain amount of and certain type of information. Like if you type pwd, it's a specific command which is already developed and recorded or stored on your system, which you can use and get the information out from the system. So whatever output you are seeing on your screen, in technical terms, it is a standard output. The standard output where you can see what system is telling us, and standard input where you send some commands and controls, like moving a mouse on your screen. It's like you are using a mouse to interact with your system using a device to navigate through a different part of your screen, and then you can click here and there and interact with system. So remember this, very important, standard input versus standard output. Standard inputs are like keyboard, mouse, and so on and so forth. And standard output is usually your screen or your terminal. But later on, we will see how you can send the output of a particular command to different files or different systems, different central place where everything can be rendered and analytic softwares can be used to analyze those set of data, and so on and so forth. So standard in, standard out, these are very basic terms, but you should know what is a standard in, standard out. So the next thing is, whenever we write a command like pwd or ls, it stores output on your screen. If I don't want to display output on my screen, but I want to store it somewhere, all of you, please execute this command. I hope you are on the same screen as we were last week, like terminal integrated with your Visual Studio Code, and you are able to run commands from there. Just confirm that.
Yes.
Good. Others? Maybe when?
Yes.
Others? Yeah, please don't sleep. Yeah, I'm working hard. Only 2 people are responding. Okay. So I'm repeating what I'm saying. All of you must follow along this session. And make sure you are on the screen where you have the Visual Studio Code open and your terminal bash or gitBash is integrated and you are able to run these commands. And if you run ls command from the training folder we created last week, you will only see a.sh or maybe whatever files you have created after that. You will probably not have this output.txt file, but I was working on something just to show you all. So now what we want to do is we want to redirect the output of the script, which we created last week, to a file. The redirection symbol is a greater than sign on your keyboard. So if you use this greater than sign, it will redirect the output, what we are seeing on the screen, to a particular file like out.txt. And if the file is not present on your system, it will create the file and add the output to the file. So please execute that and make sure you are able to see this. Execute this command, right? The dollar prompt is already there, which you are seeing here on your screen. So you don't have to type that dollar prompt, yeah? Just to be clarifying that. If you do this command, if you execute this command, what do you see? Can you see that file created? If you run ls, you will see that. Can you please confirm you are all able to do this?
Can you open that command?
Yes, sure.
We need to give space between that greater than and less than symbol.
We are not using any less than symbol.
Sorry, the direction symbol. This one.
Yeah.
Which is,
So it is, some systems will allow you, you don't have to, but after the command you have to. So if you're saying that, so a.sh and then this and then b.txt, this will
yeah.
work as well. But to make it a bit more cleaner and to see, even on your eyes, this will look a bit odd, right? You won't see what is what. That's why I recommend you use a space between them so that you can understand what we are doing. So if you do it without space, it will work in many systems. But yeah, I recommend you do put a space to make it a bit more cleaner. But depends, yeah. If you understand what you're doing, then it's fine. There are different options, it will work.
Okay, yeah, I got it. So it shows the output as 64/c.train/training.
So whichever file name you gave, in my case, I gave a b.txt here. And then I do use cat command to see the content of that file or out.txt. And in my case, I did execute it a few times in a different. So let me delete that. And if I do this again to represent it, so it will show you something like this on your screen if you are using the same script. Depends what message or what information you have stored on your a.sh file. Probably last time we echoed some message, right?
It means this message print in this file.
Yes, it redirects the output, yeah, to that file instead of showing it on the screen. So it's called redirection symbol.
If we don't make any folder, so where is the welcome to cloud? The text shows.
If you don't redirect it, it will show it on your screen. Standard output.
Okay. It means only on a terminal.
Only on terminal, yeah. So you can see it will be created, the file will be created where you are executing your script. So next to your a.sh, you can see this file is created.
Yeah.
So the next thing I was going to say that if it will create a new file called out.txt, if the out.txt is not present in the current directory, it will write the output of that script execution to the output.txt. If the file out.txt already exists, it will overwrite this. So single redirection, single symbol will overwrite that file. So for example, let me change this. Welcome to the world of open source. Welcome to the world of cloud computing, right? If I save it and if I execute that command again, then see, it will change the output of this file. Okay, you see that. So with the single redirection symbol, if the file is not present, it will create it. And if the file is there, it will overwrite that file. Okay. So to avoid that, if you want to keep the file and if you want to amend it, or if you if you want to keep adding the output of that command to the new lines on the same file, then use two redirectors, two greater than symbols. And if you use that, it will keep adding the output to that file. Every time you execute, it will add it to the file. So this is a very basic thing, but helps you with quite a few different use cases. We will see a few of them later, but you understand, right? When you don't want to display something on your screen, but if you want to store it in a file, then you can use these redirection symbols greater than and to override the file, amend the file, sorry. Following? Okay. Moving on. Let's talk about variables. So far, you have seen that last time we exported, we were dealing with some environment variables, like we were running echo $shell and then getting the output. In my case, at the moment, it is ZSH and bash. You will see user being bash in your case. In some cases, what will happen is in your day-to-day life, when you start working, you will need to perform some actions and which will need to set up a few variables. So what is a variable? A variable is a placeholder which allows you to store some values in it. For example, if I write variable OS equal to Linux, then the name of the variable is OS and the value stored in this variable is called Linux. Let's see a few more examples so we can understand what we can do with it. Setting up temporary ad hoc variables. When you are running on your shell, you can use that approach to store various variables in your environment. Let's do that. So all of you, please write a message variable, like using export command. We can create temporary variables on our screen. And then we can output that. So if you write export msg is equal to, type some message, right? If your variable's value is having special characters such as spaces, / backwards, try to make sure you put it in double quotes. Otherwise, it will only print a part of it when you try to use it. Sorry, my export. Export this. So what I have done is I'm exporting an environment variable where the name of variable is MSG, and I'm assigning a value, this statement, welcome to the world of open source. So now if I want to print it, you can use, which command you can use? Can someone say?
Echo?
Echo, yes. So as shown earlier, we can use echo command to print the value out from that variable on your screen. Right? Is everybody following? Yeah.
Yeah, it's showing.
Okay. Nilesh, you okay? Right. Dixon, are you following?
Yeah, I'm following, but it's not quite clear. I think I need to go through the notes.
Right. So
And
yeah.
also, I'm having a program now, so I may request a permission and maybe join fully next week, please.
Sorry, I couldn't get you, mate.
I said I may seek permission because I've got an appointment to attend. I don't know it's going to be until is it 12 o'clock?
Uh-huh. This will
So
be today's session will be up to 12 o'clock. Yeah.
okay. So I'll be please join fully next week.
Sure. Yeah. Once you will able to join the WhatsApp group, you haven't sent me the number, right? You send me
I've
the
sent
number?
it.
Okay.
I'll
All
send the
right.
number.
Yeah. If you can send me the number, then we will add you to the group, so you can also
Access it.
view the video tutorial, yeah, recordings from the last session and today's session.
All right.
Yeah.
Thank you so much for that.
Sure. So moving on, what we need to remember here is whenever there is a string or a variable value which has special characters or spaces in it, you will need to put quotes around it, otherwise it will not print it. For example, if I say export msg equal to this is Linux, right? And if I say echo dollar msg now, it will only print this because everything after the space has been discarded because it doesn't read by default. It doesn't read. And to make it read, we need to put quotes around it so that it takes the whole value as a variable's value. And then if you print the message, it will print the whole string. So remember this, these are very basic things, but you have to remember, otherwise you will keep bouncing into a issue. Okay, so we need to know what type of variable names we can select or we can create variables with. So to start with, just remember the variables, the name of variables contains upper or lowercase alphabets, numbers from 0 to 9, and a special sign called underscore, yeah? So variable must start with either underscore or alphabets. It cannot start with a number, okay? Based on that, can you all please set up 3 variables as per the exercise written on the screen, and try to print the values and make sure you are able to print the correct values as shown on the screen. So it's a small exercise you have to do now and confirm that you can get the right value and able to set up the right variables on your environment.
Ninit? Hello?
Yeah.
Every time if we declaring a variable means we need to use the command export before.
From the command line, yes. Let's stick to that method for now. Yeah.
Okay.
So export MSG equal to yes. So this is only when you want to do it a temporary ad hoc variable from your prompt. Okay.
Yeah.
So we will look into the better method as we go, as we progress today. So yeah, Ghanshyam has completed it. Those who are doing it and completing it, just put it into the chat so everybody else is also aware of, as well as I can know who is progressing, and if any difficulty, you let us know.
I got an error, not a valid identifier.
Identifier, okay, good. Do you want to share your screen? So, yeah, if you can, yeah. So what it is saying is, after, so look at the line above, like the second line on the, yeah, terminal, yeah, there. You have mistakenly set up a dash instead of equal to. You need to have equal to sign. You are assigning a value, right?
MSG equal to.
Exactly, because the name. So if you look at the screen, when I'm presenting screen on my screen, yeah, equal to, no, equal to. It was there, yeah.
It shows.
Enter. So now it has assigned that value to variable.
Okay.
And now if you do ECH or echo $MSG, now space, yeah, echo.
Wait.
Yeah. Enter. No, enter. Enter key, enter. Remove the equal to sign. Enter. Okay. So, okay, let me. Are you following me, Nilesh, right?
Yeah. Now you can share your screen.
So, Nilesh, the ask is to have set up three variables, MSG1, then use a variable called underscore MSG1 and underscore MSG in capital 1, and set these values, right?
Okay.
Good. Now, if you have done this, we can go further. So what happens if you want to declare multiple variables on a single line, then you can use a semicolon operator, or you can say it's a special character. It has a special meaning when you use it on the command line. In that case, you can declare multiple variables in one go, like this, as it is displayed on the screen, right? We are exporting three variables from the command prompt, and then you can use similar approach to print them all together. And there are two ways. While printing, you can either use semicolon. If you don't use semicolon, it will print the values on the same line. So I would like you all to follow this example which we have just presented on screen and try to see the difference when we use echo command.
While declaring the variable, we no need to use the double quotation, right?
No, if it has special characters or spaces in it, yes. In this case, I'm not using any special character. It's single string. So in that case, it is okay. You don't need to use quotes.
Okay.
Is everybody following? Done? Yeah.
Yes.
So you can see the difference in the output if you don't use semicolon, and if you just say echo x, y, z, all three variables, it prints out the value in a single line. But if you put a semicolon, the semicolon means execute the first command, echo $x, then terminate the output line. So go to the next line, execute echo $y, semicolon, then terminates the execution of echo $y. It goes to the third line. So that's why you are seeing three lines of output when you use semicolon. But when you don't use semicolon, this is especially for outputting it, right? Because when you export, you are using semicolon, but you may not be able to use this value because you need to have separate export for each of them. This is the limitation of command line, but we will, when we write actual scripts, we will see how we can put advanced options within the scripts. So notice that the difference between the outputs, right? Now, Now what I want you to do is, there is a second exercise we need to follow. Repeat the above both exercises by preparing a shell script called print.sh, right? So I want you, both of these exercises we did, like declaring three MSG variables using underscore uppercase and setting the values, and also this XYZ variables. So create a new script called print.sh, right? We know that, right? In the training folder, you can click on this new file icon, or you can right click and create new file, whatever is convenient to you. So you can have a new file and say print.sh. And whenever we write a shell script, what should be the first line of the script? What will be the first line of the script? Does anybody remember? So whenever we want to prepare a shell script, the first line will be always like this. In your case, make sure you use the correct cell path. It may be /usr/bin/bash. And these are the two special characters, hash and exclamation. These two characters together are known as shebang, and that shebang has a special meaning in the shell script. Whenever it executes, it tells the system that I want to use this shell to execute my script. So the first line will be always this.
Ninit, actually in my print.sh screen, it shows as nothing. So I need to copy paste that bin/bash from the.
Or you can type it in, user bin. So what is the first line in your a.sh?
It shows hash exclamatory /user/bin/bash.
Correct. So you use the same. You can you either copy paste it or you can just key in the hash exclamation slash. You can type it as well, like
Okay.
this. You
Yeah.
can key in, and then export msg equal to, this is msg1. Sorry, msg1. Then what we will do is export underscore msg1 equal to, this is underscore msg1. Then export underscore uppercase msg1 equal to, this is underscore uppercase msg1, right? So that was the first. And then you can say echo $msg1 $underscore msg1 and $underscore msg1. And then you can also do echo and then just a line to differentiate the output from first to second. And the next is, you can just copy paste that line if you want to speed up your work. And then O $x, $y, $z. So once you complete that, we will save this file. Make sure, if you see a round here, like this that dot, then it is not saved. Save it. As soon as you save it, you will see a cross there. So make sure you save the script. And then if you type ls, you will see print.sh. And then you can say dash print.sh.
Ninit?
Yep.
Yeah, I have already typed everything until the echo $x, $y, $z in the print.sh thing.
Yeah.
What is the next thing you told?
Save that and execute, like it's on my screen, right? Save it and try to run it. Now, if you try to run it like print.sh, it may not work because it doesn't have execution permissions, the script by default. So just confirm me whether you can run it like bash print.sh like this. I'll show you how to change the permissions. But as far as you can run it with command like bash and space print.sh, then let me know. All of you are able to do that? Yes? Perfect.
In the terminal one, it does not allow me to enter the text. I don't know why.
So
I still in the out.txt terminal, it seems. Whether the terminal will change for print.sh and out.txt?
So are you looking like this tabs? Is it in a tab?
Yeah, it is in the tab. I'm in print.sh tab only.
Now save that and then terminal. Where are you on the PWD when you run PWD? Are you inside the training folder?
Yes, I think initially I have copy pasted ash exclamatory user bin.bash, right? So obviously it will go to my current folder, right? The folder I created.
Okay, can you share your screen? I mean, if it's difficult to follow you, please share your screen so we can go through.
Yeah. Now, okay.
Yeah, I can see your screen. So, okay, correct. You are in the right place. If you run a command, so select the bottom panel, click your mouse on the bottom panel. Yeah. Now type ls.
That's why I'm typing.
It's not recognizing.
Yeah, I don't know any software.
Press enter a couple of times. Okay, looks like okay. You can do one thing. You can close that from the right corner. There is a cross there.
Okay.
Close it. Now go to view. Go to terminal. Yeah, you have a terminal tab. Terminal. Click on terminal on the top bar. Here. Terminal. View terminal. Oh, new terminal. That's the new terminal. Yeah, type. Or view. Inside. Go to view. Oh yeah, you are there now. Select the bash. Select bash from the right options. Right panel. Yeah. Now press enter. It's not working. Okay. Yeah. Probably there is something funny happening. Do one thing. Close your Visual Studio Code and reopen.
The entire application.
Yeah. Okay. Yeah. Yes, please. Yes. Okay. Nilesh, you following?
Yeah.
Yeah, now it's typing on.
Okay, good. Yeah, sometimes, this application may have a bit of problem. Cool.
So now what you told to display this above program?
Yes, so now type this, like if you bash space print.sh and enter.
Space print.sh.
Enter. Does it show the output, expected output?
Yeah, it shows all the expected output, which I declared above.
Yep. Okay. Now what is happening, when you do ls, can you see the color difference between a.sh and print.sh? A.sh has a green color and print.sh is white. Is it correct for all of you? Or maybe you are in a different system, it may have.
Yes, that's correct. Green color and white color difference. Yeah.
Okay. So now I want you all to run this command ls space -l. So what we are doing, we want to print all the files with details. Okay. Can you see similar output as mine? Like a.sh, out.txt, print.sh. You may have only 3 files. That's not a problem. Okay.
Yeah.
Now, if you check the leftmost column, you can see that read rwx, then r space x and r space x. This are the permissions of your file. So the X represents the execution permission so that you can execute that using // or from anywhere on the system because it is executable. The print.sh by default hasn't got that execution permission. You can see the difference, right? The a.sh and print.sh. Can you see that?
Nikit, once we close the terminal, that means in downstairs there is a terminal, right? If we close the terminal, means what we need to recover that. I
This one.
accidentally closed the X button. Yeah.
Yeah. So if you go to view on your top bar, you have a view option, right?
Yes.
In the view option, you can see there is a terminal option. You click on terminal like this. Can you see it?
Just a minute. Yeah, terminal is there. Yeah.
Yeah. So click there, it will come back. Yeah.
Okay. Thank you. Thank you so much.
So to add the execution permission, we will use a command called chmod, change mode, plus X, and the name of the file, print.sh. And then press enter. Can you please do that? And then now again, if you type ls space -l, it will show you the execution permissions are added to the new script we created, print.sh. And now you can execute it with // print.sh. Now remember one thing, we are able to use this // from the same folder where the script is located, right? So that is known as absolute path for the script. So Nilesh, Bhumit, Loga, are you all following?
Yes.
Yes, sir.
Yeah.
Jay, you sorted, right? You are able to do it now.
Yeah, I have given that chmod plus xprint.xh, but it shows like empty command only. There is no any output displaying like you.
Yeah. So if you notice carefully, it was, for me, it executed successfully. Now you type ls-l again.
Okay.
So now you can see it has the execution permission like this. Can you see this?
Yeah, I got it. That rw/r.
Yeah. X, yeah. So now, then what I did, so every time when you see this prompt, that means I am on a prompt and I'm running a command. So now you type /print.sh and then you will be able to see the output.
Yes.
Correct?
Yeah.
Okay. So all of you, as you have followed so far, we are using Visual Studio Code with the terminal interacted. It is our local environment. And we are interacting with system through a shell and a shell script. So far, we have created two shell scripts. One was a.sh, where we were just declaring a variable and printing it out. And now we saw that how we can have multiple variables and we can print multiple variables out on the screen. Now, one more thing to know, any line in your script which starts with a hash, only hash, okay, like this, is known as a comment. The comments mean it is there, but when the shell script is executing, it will ignore those lines. Okay, the lines starting with hash will be ignored. So what I'm going to do is, let's go back to print.sh and just add some command, right? Comments. So start with the hash # and say this is a comment. It will not have any effect. And then save it. And if you execute your script again, you will see exactly same output as you saw earlier, because we have not done any change which takes effect and prints anything new on your script. We have just added a comment. Now, comments are very useful when you are working in a development environment. You are writing a piece of code. So you just, it's not possible to remember everything you do. Day-to-day basis, if you do some work today, tomorrow, this week, next week, a month, 2 months. So like sometimes it is impossible to remember everything you do. So it is a good practice to add some comments in your code so that whenever you refer that, you will be able to recall what you are doing and what you were trying to perform, or what was the state of mind and why you did that. So add comments, which is going to be very useful in your code. And you can add comments anywhere on your script. You can also add comments at the end of the script as well. But make sure whenever you do that, everything after that hash will be ignored, right? So for example, if I put comment on my third, on the line number 6, on the third variable, and if I save it, right? So it won't be able to print this value. It may complain about that this doesn't exist or like that. So if I execute print.sh now, can you see that it has only printed the first variable, the second variable for the message, and there is no third value. In my previous execution, there was a value, this is _msg1 uppercase. But I have commented that line now and saved my script. When I rerun my script, it doesn't have the value because it is commented out. Got it? Are you all following me?
Yeah.
Yeah. So there is a chat window. If you want to just type and say, yes, you are following, then also it is fine. Maybe it may be difficult to unmute and mute. But yeah, just make sure you respond to us so that we know. Moving on. Okay, Nilesh has some high priority to follow, so he's left. Moving on. Let's extend our msg.sh or a.sh script, like how to interpolate your variables. So if you're declaring multiple variables and there is a possibility you need to use one variable inside the other variable's output, so how you can do that? For example, put your name on screen. Say, for example, and another variable is message, MSG. And what I'm doing is welcome to the math class, for example, or welcome to the C and AD class, for example. And then I'm calling that variable name into the first, from the first declared variable into the second variable. And then I'm going to print this out, right? So I've created another script, or you can use one of your existing scripts, a.sh, or you can create msg.sh. And then we will try to print that. I need to move this out into this folder. Okay, I can copy this. So yeah. Just extend our a.sh. So for example, in our a.sh, let's say name equals to init. Welcome to the cloud computing. And then what we are doing is we want to print the name for that variable. Variable name needs to be printed and then echo. So I'm just extending my a.sh script to add another variable and print that out as a part of the message variable. And now if you run that, you can see that the value is automatically inserted from this variable into the message string at the end. This is sometimes also known as a variable interpolation. It interprets saying that, yeah, this variable exists. So I'll print that out. Please confirm once you all finish this small exercise, though I want to show you something very important.
Unit, it shows like no such file or directory for me.
Are you trying to execute what are you trying to execute? Which script?
That name and along with the message in the a.sh.
Okay. Can you share your screen? You can have a look. Okay. So you have declared a variable called NAMW. I think the variable name is wrong. NAMW in the line number 5.
Okay.
At the end, you know where you are calling the variable on the line number 5. At the end,
Okay.
the name word is wrong. NAMW you say instead of NAME.
Okay, that's a case sensitive one.
Alphabets, yeah, missing alphabet. Yeah, now you save it and run it. You haven't saved it. Please save it.
Yeah.
Yeah. Now please execute. A.sh. Dot. Welcome in India. Perfect.
Fine. Yeah.
Now the reason you are seeing a long output because you have typed Docker there, so it is running the Docker help. If you comment line number 3, comment the line number 3.
Okay.
Or remove it. Yeah. Comment it out from. Put a hash in the beginning.
Okay.
Save it. Save it.
Yeah.
Yeah. Now please execute again. Dot slash. Yeah. So it is only showing that output.
Fine. Yeah.
Correct. Nice. Sorted. Okay. So is Loga is that all? Are you following the session? Okay, let's do a bit more of the command line interaction. Let's try and perform some mathematical operations now. In the mathematical operations, we need to have some values, and then we can use those values to add, multiply, divide, whatever. So let's start with a simple thing. Say export dollar double quotes 10 plus 20. Let's say echo. Yeah. Can you try and run this command and see, do you see whether it works on your terminal or not? Perfect. So can you all? Perfect. Are you all able to see the same result, right? So what happens, what we are trying to do is, we are telling shell to add two numbers, and this is a special format in which mathematical operations can be performed using the script. Now, we can also perform the same action by exporting variables and then using them as a placeholder to pass different values and do it. So let's quickly create a new script called sum.sh. And that script, we need to print a message, welcome to the math class, then declare two variables, num1 equal to 10 and num2 equal to 20 or whatever you like, and then add those two numbers. So basically, whatever we are performing here on terminal, we want to put it into a script and then run that script. So let's do that. I'll give you five minutes. Good. I can see concern is completed. Logo and Jay are doing. All of you done? So Roger and Jay, are you there? You done?
Yes.
Good, good. So what we are going to do now, this is a very static variable assignment, right? We need to open up a script, add a value, and every time we want to change a value, we need to edit the script. So there is another option where we can allow, while the script is executing, it will ask you for the input of, for example, enter the number 1, enter number 2, and then it will add those two numbers based on the mathematical operation we perform, or whatever, multiplication or whichever operation you want to perform. And then it will throw the output. So the special function available is the read function, which allows us to read the value we enter on the prompt while the script is executing. So let's do that. So let's say echo enter the first number, and then what will happen? We can say read 1. We will remove the static assignment. Then say echo enter the second number, then read num2. Well, what we are doing is whatever it reads, we are assigning it to a variable. And then we can say result is this, and we can say echo addition of $num1 and $num2 is $result, for example, like this. So let's execute this. What we are doing is we are asking, and you can also do this like instead of say well, enter your name, read name, right? So let's execute that now. Chmod plus x sum.sh /sum.sh. Enter your name, say init. Enter the first number, I'll say 30. Enter the second number, I'll say 50. And say addition of 30 and 50 is 80. So now we can see from just few variables on command line environment, we are able to build an interactive shell script based on whatever operations you want to do, logical operations. Usually the mathematical operations are the best to start with, and the static strings and values of strings. Right here, we are what we are doing is we are asking script to execute and ask the user to input the name, input the first variable, input the second variable, and then perform a math operation, which is addition. Are you all following me, right? It's easy to understand. Once you start doing it, it's very easy to follow. Is that correct? Are you all following me? Yep. Good. Okay, so what we will do is, as few of the other delegates were not able to join today, what we will do is we will share today's recording, and last week's recording is also available. What you can do is go through this again, practice it a bit more, and we will send you a few exercises like to complete it before next Sunday. Okay, so thanks for joining, all of you. As I said, few of the delegates are not available today, so we will have the shorter session. From last Sunday, is everybody happy to start it a bit early, around 10 or maybe before 10? Just we will go through that and chat and finalize the time, but it will be around 10 or just before 10. Thanks for joining, and have a nice rest of Sunday.